Hi, everyone. Happy New Year.
Happy New Year.
Welcome to exciting 2025. And today we have amazing project that is going to be our 10th project, and hopefully you had time to reflect on your own OKRs and your own goals for 2025. Reflect on the things you did in 2024. For LFAI and Data TAC Talks, we had so far 9 projects, and it has been amazing journey featuring all the projects and seeing the momentum of the community. We also got to have like some project announcements at LFAI and Data. We had incubated 11 projects in 2024 and also graduated 2 projects from incubation stage. So it's an amazing momentum from LFAI and Data. With that, we are hoping to keep the momentum going and even grow more community for LFAI and Data. So today I have the pleasure to host Open Model Initiative project at our TAC Talks, and we have amazing guests from OMI. Kent, let's introduce yourself. Yeah.
Hey, everybody. My name's Kent. I am, oh gosh, I don't know how to introduce myself, I guess. I'm a nerd. I'm a creative technologist. I really am passionate about creating with AI. I think that there are a lot of varying opinions out there about what AI is going to do for creatives, but I'm a very big optimist about what this could be. And I think that's where the Open Model Initiative is really well positioned to help creatives in the future. I also, as in my day job, I am the founder and CEO of a company called Invoke. Invoke started as an open source project as well. It just emerged and evolved into a very large business opportunity, but it also continues to deliver its open source interface for running these types of models. And the Open Model Initiative is really kind of a group of people from the open source community around these image generation models that emerged around the Stable Diffusion model and has kind of grown from there. And passionate folks who really want to build better models for creators to use in the future and keep those open model weights so that people have access to fine tune, customize, and use them for their creative endeavors.
This is exciting, Kent. Working at TikTok, we have been working on a lot of AI technology to empower like the product which creators use. So it's super exciting how AI is shaping those creator tools, and there's just so much going on in the creative world that is getting powered by AI. So I'm super excited on what you are doing in that space. So with that, I would love to learn more about the history, about the project itself. How did you get started on the initiative? Yeah, if you can shed some light on that.
Yeah, well, let's bring up that screen that we've got here, which will go through some of those details. First, I'll start with the charter and kind of what we set out to do. Really, I think the scope of what we're trying to do is pretty broad. It's a long-term vision, but to support open community development of baseline AI models for generative media. And I think one of the reasons for generative models being open and why that's important is that where creators find a lot of fault with AI tools today, when you talk about like public discourse, it really comes from a sense of sameness and a sense of the term derivative is kind of like there's multiple definitions of it, and it all kind of applies to what most people critique AI for. It feels very average in a way that doesn't really inspire or spark a lot of what you would traditionally believe art would be inspiring. And I think when a creative has the ability to fine tune and customize an AI model, they're changing that. They're almost creating a new perspective on culture. If you see a baseline model as almost like the sum total of culture condensed down and distilled, when an artist comes in and customizes that, they're really tuning that to their own perspective, and it becomes a much more effective tool and medium for them to use. Having those be open weight means that they can own those assets. That really does become a tool for them that they can continue to use. They're not licensing or renting that from someone else. They're building their own toolkit. And open models allow for that and create the kind of fertile soil for that type of creativity to thrive. I put together this slide, which just briefly goes through, it's only been like 2 years or a little bit over 2 years, but a lot has happened in the image generation space. So I'll put together like a little bit of a history to kind of explain what has happened in this space and what inspired the OMI to form. Stable Diffusion was released in August 2022. It was actually when I started working on Invoke. It was just an open source repo. It just had a little CLI script and actually wasn't even named Invoke. We work with one of the original maintainers is a guy by the name of Lincoln Stein, who is the head of adaptive oncology at the Ontario Institute of Cancer Research. And he just happened to want to be able to use Stable Diffusion locally on his machine. So he started this repo, and everything kind of stems from this August 2022 release of Stable Diffusion because they were open weights. People had access to the model. And for the first time, the quality of these generations was good enough to really be kind of like taken aback. Wow, I can do this on my machine locally. And the quality of these images that it's able to produce is like stunningly close to art and reality. What is possible with this new technology? And that's really where a lot of this, for many people in the community, became I would say, obsession, a full-time hobby, for some a career. This is the kind of the origin point. As time progressed, there's a lot of like open source research that has pushed this forward. ControlNet came out in February 2023. What that allowed for was it was a sidecar model that really allowed creatives to control the generation process using things like sketches or renders. Rather than just putting in text, you had the ability to guide and control that generation. The model technologies continued to evolve under Stability. SDXL was released in July 2023. It was kind of like the next generation of the Stable Diffusion model. And that's really kind of like the period of time between SDXL, July and June of 2024, where people were exploring and toying with the tools and trying to figure out how to make it better. In June, because of like financial constraints, SD3 was released, and it was released under a commercial license, in the sense that to use it commercially, you had to pay a license fee. So you did have to kind of go back and pay for commercial use of it. That really sparked this big question of what does it mean to have open weights? What does open source mean? And what do we want from our models? There were a lot of people internally at Stability who disagreed with that decision and thought that that wasn't the right move. There were a lot of people externally that kind of criticized it, including myself. And that was really kind of the spark for the OMI. And the OMI kind of really formed at that moment. We were trying to figure out exactly what and how we were going to do this. In the period after that, Stability did come back and make some license changes. A lot of those were driven by, criticisms of how it was going to support creatives and what IP ownership even looked like. In tandem with that, Black Forest Labs released their Flux Dev model, which is another open weights model, but is not open source. It has a non-commercial license as well. And so both of those models gave a lot of insight into how the market was going to evolve and emerge for these models, and really provoked the need for continued development in open source generative AI. And that's really when the OMI kind of crystallized, announced in the Linux Foundation in August of 2024, and have been working with the community since to do research to push open source generative AI forward and work towards training a model. I would say that, our ambitions were pretty high. We were hoping that we would have trained a model within the first few months, but reality is a harsh mistress, as they say. And so we're still in the process of doing a lot of that formative research, but have made significant progress. And I think are continuing to build resources that will help not just our team and contributors build a model, but others as well, because all of this is open source all of the tooling that we're building and the thinking behind how we're building better models is completely open. Any questions on that history?
Yeah, I have a one question here, Ken. So when ChatGPT and OpenAI's revolution came up, how did that impact the strategy that that started with Stable Diffusion, and what kind of like pivot that you had to do at that time?
Well, I think probably if you look at the timeline, OpenAI released ChatGPT after Stable Diffusion came out. So Stable Diffusion was kind of like, a few months before ChatGPT. I think when ChatGPT came out, it really turned on interest for generative AI broadly. It made generative AI like the buzzword. I think in some ways that's what ultimately led me to start my company. It's just that opportunity to kind of build something in this new age of technology. We didn't start, and this is not the OMI, this is Invoke. We didn't start our company until February of 2023. So, we were still just an open source project at that time, but I think that was really the catalyst for a lot of what 2023 became around generative AI companies and solutions being built.
Yeah, I think, and it also gave like a lot of limelight to research projects that were happening before OpenAI went public with ChatGPT, and like industry just bloomed.
Yeah, it did. Yeah, it did.
Yeah, that's all I have on this.
Okay, great. So now I'll just kind of dive into what the OMI is, what we're working on right now, and the two kind of working groups that we've formed. We basically have broken down the task of training this model into two primary functions. One is the machine learning working group, which is really focused around the model architecture, building out the training pipelines and optimizing that to kind of scale the training function itself. And then we have a data working group, and their main function is building an application that allows us to source data from the community, allows us to caption that data and curate that data for use by the training process. So basically the data working group is really building out the core data set, building out all of the data pipelines and processes that we'll incorporate as an organization to bring the community together and building that data set. One of the main goals for us is, we'll be launching this in the next month or so, but we've built an application that allows users to log in, create an account, upload their own assets. And so that will be through kind of like a DCO attestation process, very similar to like code, but this data is something that I'm giving to the data set. I have the rights to give it to the data set. And through that process, we're hoping to curate a large amount of training data that will pair with other public domain data sets and other resources that are available on the internet, on Hugging Face, things like that, and consolidate that into the training data set that'll go into the first model that the machine learning working group is preparing for right now. So that's kind of the breakdown of the working groups. I'll go into some of the architectural discussions that we've got and different research projects that we're currently undergoing. Overall, though, our current architectural design is intended to be competitive with what is at the moment current state of the art in the generative AI space, but with two key focuses that we're primarily trying to solve for. One, controllability for creators is absolutely critical. It is an incredibly important part of using this in a meaningful creative process. And many of the tools that exist today have control separated from the underlying model. And so if you think about the way that these models evolve, you typically have a base model and you're fine-tuning and training that on your style or your intellectual property. If the control element is separate from that base model, what ends up happening is you may not train the control piece to understand your style or understand the specific context that you've trained or fine-tuned into the base model. And so you can get some compatibility issues where quality deteriorates when you're actually using those control models. So by baking that into the architectural design from the get-go, we're hoping to solve that problem. We're also hoping that we can really build a trainable asset. So making this a primary concern for the model means thinking about who is going to be fine-tuning and training it. How do we make training accessible? What are the resources that are available to small businesses and hobbyists? How do we make this an asset that is designed from the get-go to be accessible to all on that dimension of training? And so these are the two big problems that we've tried to account for in designing the architecture.
So I think, Kent, on the control part, if we bake control into the trainability, then doesn't it jeopardize the, let's say, bespoke proprietary data that they have or intelligence that they want to create out of the model? Like, how would you envision control versus the privacy, maybe?
Yeah, so just to kind of elaborate here on what control means in this context, it might be helpful to just kind of go to this next slide. When you're training a model, you are feeding your data set, which consists of images, along with captions, and this is for like the base model, into the diffusion process. Diffusion takes those assets, adds a significant amount of noise, and then teaches the machine learning model how to regenerate the image using the caption description from that initial set of noise. So it's learning from that diffusion process how to take noise and create a picture. When it's going through training, it's doing that on images that we know and have on hand. We're teaching it to regenerate our training set. When it is used in novel applications, it's taking that capability and using them on pictures that have never existed. That's where it gets its generative capability. What control allows you to do is guide that generation process using an additional input. So if we train the ability for a model to create an image using a text prompt, we can also pass in a secondary input like a sketch or like a depth map to allow it to generate an image that conforms to that sketch or conforms to that depth map. And this is where the control transformer in this architecture comes in. What the control transformer is a separate model that has been trained to output an embedding based on a user's input depth or edge map. During training, that is going to be based on our training data. When it's deployed out to our customers, or I guess the users in this sense, they're going to be passing in their sketch during inference. So there's no real IP risk or anything like that. They're just guiding that inference process using their inputs.
Got it. Yeah, that's helpful.
The design as laid out here, I know this is a little bit technical, but just kind of explaining the way that this works. We're generating a diffusion transformer model here in this training loop, and that is the raw generative capability. What we're doing in this control transformer piece is training a model that can output an embedding that then it feeds into that diffusion transformer. And training these in parallel allows us to really tightly couple their performance and capabilities as they're going through training, but it also allows for end users to take both of these models and also do fine tuning and training in parallel if they have the resources for it. So this is a current state plan for the architecture. We're going through validation of this architecture with small scale runs. And we're still in the process of securing resources for training the full model. But overall, we're very confident that this is the direction that these models should go for really full creative flexibility and control. So to pair with that, that was kind of like the machine learning working group's current state output. The data working group has been building a number of different pipelines, a number of different utilities and tools, but I'll kind of give a high level of the goals with the data working group's outputs and then share a couple of pieces of research that we've developed along the way. When you are taking a large data set and passing it through for training, the earliest stable diffusion model didn't really have high quality captions. It effectively took the metadata of the image as it was described on the internet. Whatever description was there is basically the Layon 5B data set. Whatever metadata was associated with it, that's what went into the training process, which means the captions were relatively random and crude. Modern state-of-the-art models are trained typically using a vision LLM, right? So they take the data set, create an entirely new set of captions based on what is inside of that. And that is what we've developed captioning pipelines for as well. One of the researchers on our team, his name is Fearnworks. He has done probably some of the most extensive testing of VLLM performance across anything that I've seen, has tested all of these different methodologies and really come up with a unique way to pull a variety of different captions together for kind of like caption flexibility and synthesis. What we have here, effectively one of the early projects was developing tag-based captions, short captions, and dense captions. Short captions are going to be to enable the model to take simple prompts and generate high quality images. So when you're prompting, any of these image generation models, you might have a short description. I want to see a cat sitting on a red fire hydrant. Or you might have a very long description. I want the cat to be there. I want there to be a car in the background. It's midnight. It's dark. There's lighting from this angle. You want all of those details. The model needs to be trained with both types of captions to be performant when prompted by users with those types of prompts. And so by providing this kind of flexible set of captions and swapping these out during training, we're hopeful that the model will be capable and flexible to take multiple prompt formats. And this process that we've gone through has really taken the VLLM, orchestrated it through a pipeline to output these different types of captions for us. So this captioning pipeline is built. We've got this open sourced on our GitHub repo, and this is continually being developed as we find better and better ways to create that kind of like data set or caption type that we're going to feed into the model. This is a little bit of a chart with one of the more recent developments and thinking about how we might orchestrate captioning. And this kind of just flows from effectively using two different types of models. One is JoyCap, which goes through and essentially looks at it on from different perspectives. So I need to know what's in the image, but I also need to know how I would describe it artistically. What medium is it? What's the style? What's the vibe? How would I describe those things? What are the technical tags that I'd use? And what are the more artistic tags that I would use? And by looking at it through those different lenses, we can actually optimize and fine tune models that are basically experts for those different types of captioning tasks. We can then output those and synthesize those into a single caption that solves our captioning needs. So this is kind of the current process that's being fine-tuned and optimized right now. We haven't done a lot of the fine-tuning yet on these like more expert models because we're still kind of figuring out what the orchestration should look like. But this just kind of shows some of the current research that we're doing, and I think it's very interesting stuff.
That's amazing. Yeah.
Yeah.
So Kent, you mentioned about that performance study. Is that available anywhere for people to look at?
I don't think that it's been written up formally, but I imagine that he probably has a lot of that written down. I will check with him and see if we can, the beautiful thing about these large language models is you can throw a bunch of unstructured notes into them and say, give me a really organized doc and it'll do it for you. So maybe we can do that and get something out for people to see. Exactly. I know that a lot of that has been meticulously documented. So I'm confident we've got that, and I'll take a look and see if we can share some of that out in the repo.
Okay, that'll be amazing.
Yeah, you bet. The last piece that we're doing some research into right now, and this probably bridges into some other conversations about, model data sourcing and stuff. We're looking at style clustering. So one of the things, and this is kind of an observation, just being in the space since very early on, a lot of the early models had artist names in their data set. So I mentioned Stable Diffusion had basically all of that data and whatever metadata was associated with it sucked in. What that means is if there was a painting by an artist on the internet and it was included in that data set, that artist's name may have made it into the text encoder, may have made it into the model. And what a lot of artists were really kind of, I would say, dissatisfied with is that you could take their name, go into this model and say, give me a painting in that artist's style. I want that person's name. This is without any fine tuning. This is without trying to specialize it in any way. And because the data had been organized with that artist's name in it, the model really did create this kind of attraction basin around that artist's name specifically. Like you really could invoke that artist by name, and the weights did have some unique pocket that was dedicated to just that artist. Like that really was in the model. And, you know, we can debate copyright and fair use and all of that, but there's something about that I think really needs to be addressed. And one of the goals for the OMI is thinking about better ways to build these tools in ways that still allow for utility while respecting those individuals who don't, you know, want to have that type of in being invoked by name, having that data incorporated in that way into the data set. And so what style clustering is aiming to do is, rather than organizing that data by artist, organizing data such that it is useful for an artist who's describing the style, describing the medium. So oil paintings in this certain type of style. But because it's not organized by artist name, it'll learn a general understanding of that style, that medium, the aesthetic. But because it includes a variety of artists and a variety of different perspectives, it really is going to have more of a generalized look and feel to it that adheres to that style and is clustered around that style, but is not clustered around that individual artist. And so in this way, you're not relying on referencing individuals by name. You have a more useful tool in a lot of ways for creatives and artists. And I believe in the future, what we'll likely see is artists and creatives will fine tune and train this on top of their work and use their custom model for their projects. What you really want to have is a good basis for that. And that's what we're looking to build with the OMI. I also have some futurist takes. I think probably artists will want to be in these models at some point in the future, once it's like you've kind of made it. If you're included in one of these models in some way, you've got enough data to be there. But for now, I think where we're at with society and the technologies, we really need to find a way for the technology to respect artists and creatives and kind of create a good starting point for them to work from.
Yeah, we would definitely need to like dive into fairness and ethical usage of creatives, because that's the only good way to progress on this AI models.
Yep. So I think that's my last slide. I don't think I have any more. So maybe we can just continue the conversation. You can ask me a couple of questions if you got any.
Yeah, Ken. So I'm curious, like there's a lot of work being done, and this is like the base of where 2025 is going. We are also seeing like a lot of creatives doing videos with generative AI. So I want your take on like, where do you see technology going in 2025? What are your like inputs there? I know it's a very big question.
Well, I find myself in the unique position of being extremely optimistic and probably overly aggressive with my estimations on how quickly things will change. I think I even saw this. I think I had a prediction that 2024 was the year that like everyone was going to start adopting this, and we're in 2025, and that's still like I still feel like that's like in the future, right? We're still early on this. But it does really feel like 2025 is the year where a lot of these conversations are changing. We're at Invoke, which is separate from the OMI. We're having a lot of conversations with artists because artists are using our tool. We've worked with, an artist who's now going to be having a show at the Gagosian in Paris, right? Oh, wow. And so the fact that he's got a show that's focused on generative AI and is kind of like provoking that conversation, it just means that we're at a different point in the conversation about AI. I think 2025 is going to be really interesting. I think video is going to get better and better. We've got really good models today. On the closed source side, Google's VO2 is extremely good. And there are open video models, like Hunwan came out with a video model, or there's a Hunwan video model that is open weights, and people are doing incredible stuff with that. So I think video is here. 2025 is the year of really good video. I think we may also see 3D start to get really good this year as well. And I'm just ultimately really excited by the power and the capability that is coming. Where I think a lot of people are still dissatisfied with the current technology is the lack of controllability. It still kind of feels like you're going to Vegas and saying, give me a good image, give me a good picture, right? And that's where I think image has made a lot of progress in the past 2 years. I think we'll get to that same degree of progress on video and 3D. I don't know that that'll all happen this year, but controllability and really being able to iterate on it as a professional is going to come down to better tooling, better like ways that you can run inference, but also better ways to train the model on what you're looking for it to be able to do. And I think those two things hand in hand are really where the opportunities are to advance the state of generative AI in 2025. But I am very excited about 2025. Optimistically, I would say that we're going to have some really big releases this year. It's going to be fun.
That's amazing, Kent. Anything that you can share? What is coming up at Invoke? What are some milestones? Or
for Invoke specifically, our most recent launch was actually a lot of open source work. So we're doing a lot of work to make this more accessible. We recently, I think a lot of people for the past 2 years have satisficed with, I've got a script that can install an application for me. We recently just launched our executable launcher. So it's a code signed installer. You can download and just run it. It's all packaged. It sets up like the Python environment for you. It gets everything ready. So part of what we're trying to do is make it more accessible so that people actually can use this without being super heavily technical. And I think going into 2025, we'll see some pretty interesting stuff that we're working on around training and making these models better for artists and creatives.
awesome. And Kent, I would like you to share some resources for the community where they can actually access these models, where they can maybe speak to you if they want to partner with you. Where can they go?
Yeah, so we were privileged to work with the Linux Foundation to get our site together. It's openmodel.foundation. That includes links to our GitHub repo, our Discord. Discord is, for whatever reason, where a lot of open source AI conversations happen. Our Discord has about 1,900 folks in it, from users to ML researchers and PhD students. It's got a whole host of folks that are interested in this space. That's probably the best place to engage with us if you're interested in participating in the project. But the link to our GitHub repo is going to be where you'll be able to kind of download and interface with any of the artifacts that the team's producing. We do have bi-weekly all hands meetings in the Discord. That's kind of where we report out on status and kind of have discussions around open issues. One of the current discussions that's kind of been more heavily discussed and controversial is our discussion around model standards. So right now it's kind of like the Wild West when it comes to these model formats and how they're organized, how they're distributed. And we're really trying to bring all of the ecosystem partners in, including training script developers, including application developers, to standardize on that, to make users' lives easier, but also all of the developers who are building on this stuff, making it a little bit easier for them as well.
That's awesome. And Kent, I'm curious, you're doing a lot. How many people are working on this project?
The OMI has it's all contributors, right? It's people who are volunteering their time. Yes. I would say the core team, I went through and counted the thank yous for 2024 on our announcements. And I think that we've got about 10 to 12 heavily involved folks that are taking on a different aspect of the project. We have some folks who are helping with standards conversations. We're having some folks that are working on the data pipelines, organizing, security best practices for our repo, doing the work to make this a sustainable and maintainable project. So a lot of really good folks that have given a lot of time to make this a reality.
Yeah, it's amazing how open source community can come together and help advance this initiative forward, and that's why we are in this space where we can actually do a lot of things without coding, I guess.
Yeah, it's exciting times.
Yeah, awesome, Kent. So with that, I think we are coming to a close for this session. Any last thoughts? Anything that you want to share with the community?
No, just keep supporting open source AI. I think it's going to be incredibly important, not just in the near term, but the long term.
Awesome. And with all of and for all of you, we have released a 2024 report just yesterday, so you can find that on our Linux Foundation LFAI and data website. That report has all the projects listed, what is going on in the community, what projects we have worked on, and the ways that you can contribute back. So please check that out. I will share the link in the chat here. And with that, we are coming to the close. I do want to share this TAC Talks happen every other Tuesday at 9 a.m. PST. And I really want to thank Kent for taking his time and sharing very insightful thoughts, very insightful directions on where the technology is heading in 2025. So thank you, Kent. And hopefully we can work together more on these TAC Talks in the future.
Absolutely. Take care, everybody.
Thank you. Bye.